G'day everyone, how's it going? And welcome to my misconception of dark matter and energy. Done a bit of a write-up, so I'm hoping that, let's see, I've just got to go there. Just got to set up the chat first, guys. Let's see, I do apologise. Here we go. So, what I wrote down is, so we can start somewhere, and what we're trying to do is we're trying to look at why do we need to refer to dark matter and dark energy? I mean, it's matter, whatever it is that's that we can't see or detect. It's matter. Right, so therefore it's a mass, and therefore it's an energetic mass. So that's what I think. Anyway, let me just read what I was going to say. All right, to understand the universe, aka everything, right? I mean, everything is the universe, right? We must do the following, right? One, we must briefly forget about a particle sort of universe, where things are particles separated by space, empty space. I don't know what the particle physicists are thinking there. And what I'd like to do is treat the whole universe as a mass, and an energetic mass, because if you think about it, I mean, how are things going to change? Something has to sort of give something kind of give, so that exchanges can happen. So yeah, eventually we will get back to particles. So let me read further on. Number 2, treat everything. Well, I've already covered number 2. Treat everything. What I'll do is I'll just put that down. This is where I'm at. Consider the universe based upon a non-contradictory construct. Ergo, it is a finite system. And of course, if we're referring to everything, there's nothing left to consider, right? So therefore, it's a closed system. Nothing can be inputted to it. Nothing can be outputted from it. So therefore, if something happens, there's something else that should reciprocate, and therefore our sum should always equal the sum of 1, because there's only one system, the universe, and that with everything. There can't be multi-universes or multi-everythings, and there can't be parallel everythings. It has to be one, and that's it. Done. That way, and only that way, can we do a sum, and the sum adds up. There's no remainder, or there's nothing, to be made to something, or something made to be nothing. This means the universe has always existed, and therefore the Big Bang model, any Big Bang model that refers to a start from nothing, or from some primordial soup or whatever. I mean, let's think about it. What created that soup then? I mean, what? Anyway, moving on. Right. Let's see. If we now have a single inference that if summed equates to 1. I'll just cover that. Everything is a portion or a percentage of this single system. It's a closed system, isolated system. Therefore, everything must be treated to consist of a single constituent. And I prefer to call the universe as a mass, right? And everything that we know and see, touch, it's a mass. And we have to work out how this mass can be so interchangeable and present in so many different ways. Simple as that, right? So if we look at two masses, one is more energetic than the other, and let's say one is not as energetic, which is going to have the more of you could say, repulsion. The one that's more energetic, right? So what we have to now sort of look at is the near vacuum. Is that more energetic than a mass where all the energy has been stored, therefore it's more solid? Think about it. What's going to end up being pushed around? The sluggish, energetic, non-energetic mass, or something that's highly energetic? So, it's obviously that, we're looking now at particles. But how are these particles made? Fusion? Lighter atoms made into heavy atoms. But what about what's lighter than hydrogen? What's more energetic than hydrogen? Near vacuum? I'd say so. Where's this near vacuum? How does it get compressed and stored to become an atom of hydrogen? Is it in the cloud nebulas? I don't know. Well, fusion, lighter atoms into heavy atoms. But what's before that? What's earlier than that? Or what creates the hydrogen atoms? Obviously, spaces of near vacuum. If we start compressing that, what happens? It's more. It gets heavier. It becomes less energetic. So is there something less than hydrogen or lighter than lighter than hydrogen? I don't know. I don't think so. I reckon hydrogen is actually the lightest, and we've got actually a periodic table that we can refer to for that. So, moving on to fusion now, lighter atoms into heavier atoms. Every star is doing this. And I don't know, has anyone thought when there's two or more lighter atoms being merged into a heavy atom, excuse me, that space that's left over, what takes that over? It has to be the near vacuum, doesn't it? And if the near vacuum is expanding into that, obviously it's gained energy. And guess what? Accelerating expansion. It's as simple as that, folks. Accelerating expansion, making us think, well, the universe is expanding and it's accelerating. Things are going further and further apart. We even see redshift, and redshift proves it, that it's seemingly they're moving away. But see, what happens if each and every galaxy, as it is moving inwards and being compressed ever so smaller compared or relative to the near vacuum, and as we actually shrink or we lose energy, what happens? Time slows. Events take longer to take effect. The electromagnetic waves shift to a red. It all makes sense. The universe isn't expanding. It's not accelerating expansion. I guess it is, but it's not going outward. It's actually accelerating inwards, taking over the spaces where every single time lighter atoms fuse into a heavy atom, that leftover space is taken over by the near vacuum. Am I right? Leave a comment. I've got the chat open. I know there's someone else watching, so what do you think? Because, I can't say much and I can't react to, to my own self. I need other people's input to let me know. Am I right? Am I right to think that the Big Bang is actually not a Big Bang? It's just a change of states, where I reckon the whole universe is, it's more or less a waveform. So we're just going to sit here like dorks if you don't enter into the chat. Just say hi, at least. Now, I'll get rid of this, my little guide. And, yeah. I mean, you see so many things of different ideas about dark matter and dark energy, and I don't know, I think there's something missing. I think people are not looking at it correctly. So yeah, as quick as this as quick as this is going to be, if no one's going to enter into the conversation, I mean, it's just pointless me just saying nothing. I mean, I got nothing more to say unless there's someone else going to help me and put some input or ask a question away. Where am I wrong? See, I honestly believe, like, if we look at a particle, right, and if we look at another one and they're separated, you know, I want to know what's in between those particles. It can't be empty. It has to be something. You know what I mean? And this is what the particle physics is all about. It's treating particles, but it's overlooking the fact that these particles are separated. I mean, what distincts, a particle or an area that's defined as a particle to another different particle, or maybe much the same particle? What separates them? If they're not separated, they have to be conjoined. And if they're conjoined, what is the actual difference from what, defining one particle and to another particle? I mean, there has to be a difference. There has to be some way of identifying which particle is which or what particle is where. No such thing as empty space, a dimensionless space. It has to have a dimension. It has to have something to to point to or refer to. It can't be nothing and that's that, because nothing has got no dimensions. Therefore, you can't put a dimension to it by a separation from one particle, or separating the particle from another particle. It has to have something. I mean, you look at space, outer space. Everyone used to look at it and refer to it as empty space, but it's not. We now know that it's electromagnetic waves going through it. So therefore, there's a rise and fall in potential as that wave is propagated. And the further away the source of light comes from, the further back in time we're looking at, which is another thing. I mean, if we look at some long distance, say a couple of million years backwards in time, and if that's been redshifting, if that's redshifting faster, what's the story? Is the universe, actually slowing down? You know what I mean? Is it speeding up? I reckon my answer's the best. So yeah, feel free to go over this video. Feel free to mull over it. And leave some comments down below. Take your time, and I'll see if I can answer it on my next live feed. Now, I'm not going to drop a live feed until someone drops like a comment down below or in the actual chat. So yeah, I'd like to thank you for watching and participating. Wow, watching. I don't know. Maybe I'm just going insane. Maybe I'm just, I don't know. I'm hungry to know, I mean, look at this graph here, right? I can't actually go on it. I can use it, I believe. I mean, it says 28% dark matter. I mean, might as well just be matter. And that might as well just be mass, mass energy. What is ordinary matter, I mean, to me, this is what we have tested so far, and we can conclusively identify and work with. So, this is all done and worked out, but this is what the mystery is. And I think the mystery is it's just a simple matter of understanding that this whole universe is mass, and, as energy is stored, I don't know if there's any depiction of how actually energy is stored. I mean, I can probably try and look. Do a Google on stored energy or energy being stored. I doubt if we'll ever get a model. But I always figured, like, if this picture merged with this picture, right, these two would merge, and then all these would be pinched. Like, just say, well, let's have a look at it. Just say this picture was merged with this one, and this one. These all would merge into like you see in relativity. Now that is wrong, that depiction there. Right? Imagine this actual one plane, this single plane was pinched. These would all sort of triangulate to where the pinch mark is, actually. See, and that's only one plane. If we go 360 degrees, this is going to be a problem, this dip. It's wrong. It should be, see how this is sort of triangulating? It should be a flat plane, and it should be more solid in the center, right? Because this square's been moved into a square there and so forth. It's been compressed, and therefore it's a particle. And therefore, like if we got an image of 2, like see how we got 2 here? It should be a flat, but there should be a solid there and there should be a solid there, right? And what's happened is because all this near vacuum and it's highly energetic, it actually starts pushing these two together, because from this galaxy to here, this has got a lot more energy than from this galaxy to this galaxy. This has got in between here, there's a highly energetic repulsion, but this has got more energy. So therefore, it's going to push these two together. And that's how I see general relativity is actually, showing us that gravity is actually a repulsion, not some magical attraction. I mean, you try to explain attraction without some kind of form of repulsion. As soon as you start trying to, explain how this attraction works, right, immediately you start referring to repulsion. Everything's repulsive. The near vacuum, highly energetic repulsion, and therefore it's pushing these two. Well, we could treat these as the 2 lightest atoms, and they're going to be merged into a heavier atom. And what's going to happen is there's going to be a space left over, and guess what takes over? The near vacuum. The near vacuum gets more energetic because it's moved them inwards to each other. So therefore, you're feeling the gravitational push from the near vacuum. Now, I've said enough. I'm hoping this is enough to talk about, and to let me know. Give me a thumbs up if you agree. Give me a thumbs down if you disagree. But if you disagree, I want to know why you disagree. Spell it out. I don't care how scientific it is. You can get into the maths. I'll work it out for you, and I'll show you. What is where you're probably missing out on. What you're missing out on. That dark matter has to actually be a scientific definition, or dark energy as well. I reckon it's just matter and energy, or mass and energy. I prefer mass and energy because I treat the whole universe as a single mass, and the near vacuum is the most highly energetic mass, and therefore it's storing less energetic mass into each other. That's fusion. But that's what we observe in the stars. We are observing everything going towards the center of the galaxy. We're observing everything going towards the sun, because what happens is as lighter atoms emerge into heavier ones, there's space left over, the near vacuum takes over, it expands, and the more fusion that happens, naturally the quicker the accelerator, or the quicker we think the expansion is happening. Well, which in effect it is true when you think of it, because the more energetic the near vacuum gets, the quicker the more repulsion we'll experience, the more gravity we'll feel, and we actually will slow down in time, because what happens is as we get compressed, our density increases, and as density increases, it's been proven, just like in Bose-Einstein condensate with the speed of light, where we can actually slow the speed of light down. And what happens is our local time will actually slow, or events will slow down as we get slowly more and more compressed. So therefore it seems that relative to what's happening to the near vacuum, which is actually getting more energetic, and therefore what it does is actually gaining momentum. So therefore we're seeing an acceleration of the expansion. But it's not expanding outward, it's expanding more or less into the spaces where fusion happens. And I think that's where every single physicist is just not looking into. They don't understand how mass and energy are exchanged. I mean, they should, because we know actually how to unleash the fury of energy via the atom bomb. And we also know and understand how fusion happens in the sun, where lighter atoms are fused into heavier atoms. So, I don't know why they're overlooking that fact. Am I looking too much into the bigger picture, and have I delved into general relativity and special relativity too much? I don't know. To me, it seems like the Big Bang is a big bust. It, it just does not describe anything about our universe in actual reality. It's just a model that's, I don't know, haphazard. But I'm only talking about the Big Bang models that insist there's a creation point. Like if there's no time, no change can happen. It's as simple as that. So that, if there's time and there's changes, that means there's something there that is changing or being exchanged, and therefore the Big Bang that insists it's like a creation point of the universe. That's utter rubbish, nonsense, isn't it? I'm ranting. Okay, well, I'll catch you in the next video, but I'm not going to live stream again until I get a response. So yeah, thanks for watching. I hope I've made sense to you, and I hope you've fully understood more or less what I've said, and hopefully, you've given me a chance and listened to what I've had to say. So yeah, if you want to have a say, just comment down below, drop a like. Thanks for watching, and I hope to watch you. Hope you come to my channel again. Bye for now.